Hey guys, let's go over horizontal projectiles here real quick. So, first of all, we got to talk about what is a projectile in general. So, a projectile is any object upon which only the force of gravity is acting on it. In other words, it's something that's in free fall. You could drop something straight down, that's a projectile, throw it straight up, or throw it to the side. Those would all be projectiles. So, to talk about them, let's imagine this. Imagine a cannon is fired in a world with no gravity. If this cannon was fired, and here's our little blue cannonball here, since there are no forces acting in the horizontal direction on this cannon at all to pull it down, and there's no air resistance, so there's no downward forces because there's no gravity, and there's no horizontal forces because let's say there's no air resistance, then it's going to just keep going a constant speed. So a cannon fired on a world with no gravity would go a constant horizontal speed here. What about if we just straight up drop a cannonball with gravity? Let's focus on this motion right here. Well, we've already studied this. We've already talked about free fall. So we know that the acceleration due to gravity is approximately negative 10 meters per second per second. We know if we just drop it that our initial velocity is 0 meters per second. So the motion horizontally is independent of the motion vertically. They do not affect each other. So if you fire it faster to the side, that has no effect on the acceleration due to gravity downwards. So keep that in mind. It's one of the most important concepts of projectiles. The horizontal motion is independent of the vertical motion. So what we do is we combine the two together. Horizontally, if we make a little motion map here, our ball is equally spaced out because it's going at constant speed. Vertically, we can see the spacing increases because we are accelerating. So where's the ball actually? Those are the red dots. It is horizontally where it would be at a constant speed and vertically where it would be if you just straight dropped it. So if you combine those two paths together, the horizontal with the vertical, you can see we get this curved path. More specifically, it's a parabolic path there. So what happens to the velocities? Well, we've got two different velocities we want to keep track of. The velocity in the horizontal direction, we'll call that Vx. Vx, is, as we've said, is a constant. So let's pretend we shot it to the side at 20 meters per second. Vx would stay 20 meters per second the whole time. It would never change. We could have another velocity, Vy, the vertical velocity. It starts out at 0, and that's not labeled here, but 1 second later it'd be negative 10 meters per second, 1 second later negative 20 meters per second, negative 30, negative 40, and then negative 50 meters per second. So vertically, it will gain 10 meters per second of speed just as if we've dropped it. So it's doing both things at once, constant horizontal speed and increasing vertical speed. So let's look at, here's just a little animation you can watch there. The horizontal speed remains constant and the vertical speed is increasing. Same thing would happen if you were on a plane. The horizontal speed would remain constant, so it stays underneath the plane if you drop some cargo, but the vertical speed starts to increase and it moves more and more distance downwards. You can watch this video. The presentation's linked in the Google or in the Schoology folder. So what if you drop a bullet and shoot a bullet to the side from the same height? Which one will hit the ground first? Well, as we've just said, the horizontal motion is independent of the vertical motion. Sorry for that interruption. Since the horizontal motion has nothing to do with the vertical motion, these vertically are exactly the same thing. They're dropped from rest from the same height vertically, so they'll hit the ground at the same time. And you can watch this little video on that on your own time here. I got a little video from Mythbusters. So let's also talk about where the ball is after a certain amount of time, like its position. We've talked about its velocity. So horizontally, we'll follow this equation. Its position horizontally, its x position, will be its horizontal velocity times time. We can use this equation because it's going a constant speed to the side. So we'll continue this in the second video on this, and we'll pick up there.